Hello everyone, my name is Gennaro Notomista, and today I'll be presenting the work I've done together with Sebastian and Magnus Egerstedt on persistification of robotic tasks using control barrier functions. So let's talk about persistification. First of all, how you even spell it, and second, what it means. Well, the first question is easy, so let's focus on the second one. Persistifying a robotic task means rendering it persistent, in the sense that it can be executed forever. In practice, this means that the robots executing the task never run out of battery. Now, how can persistification be realized? Let us start from the model of most robots, the so-called control-affine model, and augmented state from X to Chi by adding the energy stored in the battery of each robot. We assume the compound model still remains affine in the control input. Ensuring that robots' batteries never deplete is equivalent to saying that their energy is always greater than zero. Since the energy is one of the robot's augmented states, we can express the constraint on the energy as a constraint on the state, h of chi greater than or equal to zero. Technically speaking, a task is persistified if the zero superlevel set of the function h is forward invariant. At this point, we can leverage a nonlinear control technique known as control barrier functions to render this set forward invariant. Control barrier functions provide an inequality constraint that, if satisfied, allows the robot to never run out of battery and to continuously execute the given task. In particular, if the robot model is affine, this constraint is an affine constraint in the robot input. Let's see how the persistification strategy works in a real experiment. The presented experiment consists in persistent sensor coverage. The robots are requested to spread over an environment, here in the video represented by the workspace of the Robotarium, a remotely accessible swarm robotics research testbed. A coverage control algorithm provides the nominal input unom, but what the robots actually execute is u star, the solution of an optimization problem. The robots execute coverage control as good as possible, provided that they don't run out of battery. Mathematically speaking, this is realized by minimizing the difference from the nominal controller such that the constraints encoded using control barrier functions are satisfied. The resulting behavior, as shown in the video, is a persistent coverage control. The robots cover the given area under nominal controller and go back to charging stations on the left of the screen when the energy in their battery is depleting. I'm looking forward to further discussing with you the described robotic task persistification approach at the interactive session. Thank you very much.